when we're wanting to determine probabilities, we're going to look at our sample space and the probability of an event over long running fractions of time. The event will occur a given number of repetitions, as long as it's under identical circumstances. When a probability is determined by observing outcomes of experiments, it is said to be determined experimentally or empirically, meaning we look at the actual results. We identify what's exactly happening. Bernoulli's theorem, the law of large numbers, it states if an experiment is repeated a large number of times, the experimental probability of a particular outcome approaches a fixed number as the number of repetitions increases. And that fixed number is what we consider the theoretical probability. So think about flipping a coin, okay? So, we have a coin and we have heads or tails. So if you think about it, the probability of getting a head is 1/2. Half the time we should be getting a head. Well, if I flip a coin, say, 4 times, am I really going to get a head 2 times and a tail 2 times? Not usually. And so that's why that would be more of an experimental, empirical type of probability. We're observing those events of what is actually happening. This would also be like if you're on the basketball team and you're shooting free throws. Well, there's only 2 outcomes. So you should be making your free throws half the time. Now, that's not usually what happens. Bernoulli's theorem says, okay, if we do it 1,000 times, let's say if we flip a coin 1,000 times, then we've repeated it enough times that we will then have half the time being head and half the time being a tail. So the more we repeat it, the more we get closer to that theoretical probability. And so that's what we're actually going to do, is we're going to look more towards the theoretical probability than what is more the empirical, for the most part anyway. Theoretical probabilities are assigned to the outcomes under ideal conditions. That's with nothing weighing on them. Everything is equally likely when we talk about most of these, such as a coin toss, rolling of the die. There's nothing weighing on it. There's no conditions on it. And again, if an experiment is repeated enough times, then it will become closer and closer to that theoretical probability. So for a probability of an event with equally likely outcomes, for an experiment with sample space S with equally likely outcomes, the probability of event A is given by the number of elements in A divided by the number of elements of your sample space. So we're going to take how many times does that particular thing occur divided by the total number of times anything can occur. And many of us are familiar with that. Now, this only applies to those equally likely outcomes. Okay? If each possible outcome of the sample space is equally likely, the sample space is a uniform sample space. Like rolling a die. Everything has a 1/6 probability because you have 6 sides. And so everything has that 1 out of 6 possibility. That's a uniform sample space. Okay? So let's look at the set A, 1 through 8. And we want to calculate the probability for each of the following. Event A is that an even number is drawn. Well, if our event A is an even number, that's the probability of an even number. So that's the probability that I draw a 2, a 4, a 6, or an 8. So I have a total of 8 possible outcomes, because 1, 2, 3, 4, 5, 6, 7, and 8. And in this sample space, I have 4 outcomes. So that's 4 out of 8, which will give me basically half the time. I simplify those fractions. B is the probability that a number more than 5 is drawn. So that's the probability that we get a 6, 7, or an 8. So that's going to be where we have 1, 2, and 3. So that's 3 out of 8. C is a prime number. Now, one of the things that you have to remember on prime numbers is that 1 is neither prime nor composite, so 1 is not included. 2, 3, 5, and 7 are included. So that would be 4 out of 8 again. So that's 1/2 of the time. D is probability that an even number that is a multiple of 3 is drawn. So let's go back up here. An even number, which is 2, 4, 6, and 8, that is a multiple of 3. Well, the only one that is 6. So the probability of a 6 being drawn is just 1 out of 8. Probability of drawing either a prime or a composite number. This would include the 2, 3, 4, 5, 6, 7, and 8. Again, this would not include the 1, because that is neither prime nor composite. So this would actually be 7 out of 8. Probability of drawing a number less than 1? Well, we don't have any numbers less than 1, so that's 0 out of 8, which is just 0. Probability of drawing a number greater than 0, well, that's 1, 2, 3, 4, 5, 6, 7, 8, so that's all of them. So that's 8 out of 8, which is 1. So let's look at some of the rules for probabilities. An event that has no outcomes is an impossible event and has a probability of 0. Look right here. A number less than 1. We couldn't draw a number less than 1 because there wasn't a number less than 1. So that's a probability of 0. An event that has a probability of 1 is a certain event. It's gotta happen. Drawing a number greater than 0? Well, all of our numbers were greater than 0. So that's 8 out of 8, which is 1. If A is an event and S is the sample space, then the probabilities have to be somewhere between 0 and 1. You cannot have a probability that is greater than 1, and you cannot have a probability that is less than 0, meaning negative. They can be equal to 0 and they can be equal to 1. You just cannot have them outside of there. So let's look at this example 4. In a movie theater, 50 people have popcorn and 35 people do not. What is the probability that a randomly selected person has popcorn? So we look at the probability that someone has popcorn. Well, we know that 50 people do. Then we have to look at the total number of people. So that's 50 plus 35. So we get 50 over 85 people. So it's 50 out of 85, and we simplify that, and we get 10 out of 17. Now you can divide that and get a decimal if you would like. I'm just going to leave it there. Okay? I want to look at one more problem for right now, and that is a multiple choice test has 5 choices for each problem. What is the probability that if you guess, you will guess incorrectly? We're talking about a multiple choice problem. So you have 5 choices. You have A, B, C, D, and E. Well, on a multiple choice test, one of these is correct. So how many are incorrect? Probability of an incorrect answer is 4 out of 5.